Hi, welcome to 5 Minute Physics. I wasn't planning to do any more of these for a while, but someone did ask an interesting question and wondered whether in 5 minutes I could talk about the end of the universe instead of just the beginning of the universe. So I thought I'd give it a shot. It's something I've written a lot about, both professionally and in popular writing. The first thing to realize is that, in some sense, one thing that we all thought was true 25 or 30 years ago was not true. We used to think that the future of the universe would depend upon the geometry of the universe. That if the universe was closed, it would expand and one day stop and recollapse. If it was open, it would expand forever. And if it was flat, that's the boundary between open and closed, it would expand forever, slowing down, and almost stopping, but never quite stopping. And that was one of the reasons I got into cosmology, as I've often said, because I wanted to know which universe we lived in. I'd want to be the first person to know the future of the universe or how the universe would end. It seemed like a good idea at the time. But in fact, it was misplaced because, and in fact, I wrote a paper in 1999 with a colleague showing that geometry is now irrelevant. Once you realize that empty space can have energy, and our empty space apparently does have energy in it, that's gravitation repulsive, and it's causing the expansion of the universe to accelerate. You can show that independent of the geometry of the universe, if the energy of empty space takes over while the universe is still expanding, as is the case for us right now, then it will expand forever, independent of whether the universe is open, closed, or flat. So you might say, okay, well, look, we have this energy in empty space. We therefore know the universe will expand forever and accelerate. And I'll get to that in a bit. But in fact, you really can't say that because we don't know if the energy we're measuring in space right now that's causing the acceleration of the universe is fundamental. Maybe it's due to some field that's going to disappear and that energy will be released in matter and radiation, in which case that acceleration will stop. And then if there were no energy in empty space left, it would once again depend upon whether the universe is open, closed, or flat. And if the universe were closed, then it would start to recollapse. But you might say, okay, well, let's say that energy goes away and we measure the universe to be closed. We don't know if there's not an energy in empty space that's lower in value than anything we could measure now or in the future, because eventually, if it takes over, the energy density of matter will continue to decrease. And if there's some energy in empty space that takes over before the universe starts to recollapse, then the universe will once again start to expand faster and faster. So unless you know about all the kinds of possible energies of empty space, you don't know whether the universe is going to expand forever. And in fact, you might say, what if we discover the universe is open? Then it doesn't really matter whether there's energy in empty space, it's going to expand forever. But there can be actually an energy in empty space which is negative. And if that energy is negative, it can eventually overcome become the dominant energy, if you wish, of everything, and then in which case the universe will start to collapse again. So unless we basically have a theory of everything, we really can't say with absolute certainty what the future of the universe will be, which is kind of nice. It's nice to have an ultimate mystery. And as I've often said, well, you'd have to be around forever to know the answer, but we've also written that life forms can't be around forever. Another big debate I used to have with Freeman Dyson. But now, having said that, let's go back. We are living in a universe that's expanding and accelerating faster and faster, and it appears to be dominated by the energy of empty space. If that persists, what will the future of the universe be? Well, the interesting thing is, again, something else that we first wrote about in, I think, 2000, is that as the universe expands faster and faster and faster, the interesting thing about it is that we'll see less and less of the universe. Because eventually objects far enough away from us will be moving away from us faster than light. Now, that sounds impossible in special relativity, but in fact, in general relativity, you have to be a little more careful. These objects are at rest in space, but space is expanding, and the relative separation of objects is increasing faster than light. So one of those objects can emit a light ray and it'll travel at the speed of light in space, but space is expanding away fast enough that the light ray will never make it to us. Kind of like a surfer caught in one of those I forget what they're called now, one of those things where you get swept out to sea. The surfer or the swimmer can be undertow. Okay, so the surfer or the swimmer can be swimming as fast as they can, but if the water's carrying them out faster than they can swim, they never make it back to shore. So this is interesting. In a universe that isn't expanding exponentially fast or accelerating, The longer you wait, the more you can see, because the longer you wait, light from further and further objects will get to you. But in a universe such as ours, the longer you wait, the less you see. Because right now, there are objects that are moving away from us, separating from us faster than light, that were once not doing so, and we can't see them now. They're invisible to us. If we'd evolved 5 billion years earlier, maybe we could have seen them in principle. Similarly, in the future, civilizations that may arise in the future will look out and they'll be able to see less and less of the universe. And we calculated that in about 10 trillion years, all objects outside of our local supercluster, which are bound to us right now, and therefore not expanding with the expansion, all other objects, all of the galaxies will now have moved away, be moving away faster than light, and will have disappeared. The rest of the universe will have disappeared in about 10 trillion years. So, by the way, that may seem like a long time, and it is, but compared to the lifetime of the longest living stars, it's shorter than that. So there'll be main sequence stars in the Milky Way galaxy that'll still be around, and civilizations that may be around them living, that will look out and see nothing other than our own cluster of galaxies. And by the way, eventually, all the objects in our cluster of galaxies will collide together to form one massive galaxy. So it's kind of interesting, it's kind of poetic, as I've said, is that before in public, is that in the far future, 100 years ago, we thought we lived in our galaxy was the universe. We thought the rest of space was empty and dark and eternal, and our galaxy was all there is. In the far future, when civilizations look out from that galaxy, they'll see an eternal, dark, empty space. They'll have no evidence that the universe is accelerating because there's no galaxies in there to probe. The microwave background, which is evidence of the Big Bang in some sense, which I won't be able to talk about now, but will have disappeared. It won't be able to permeate the galaxy. And so in some sense, there'll be no evidence that there was a Big Bang or that there's an expansion in the very, very far future of the universe after 10 trillion years, if the energy of empty space is all there is. And if it dominates and stays the same, it doesn't change. All of those are big ifs. Now, after that point, after the 10 trillion years, when our galaxy is all there is and we're alone in a dark, empty space, what will happen? Well, eventually the stars will burn out. And eventually they may coalesce into some large black hole, which will then, in principle, evaporate after an extremely long time, leaving space cold, dark, and empty. So that's the future of the universe in the long run. It will end with not a bang, but a whimper, if the energy of empty space dominates. And it'll be cold, dark, and empty. And so it ends badly. So that's the future of the universe in 8 minutes instead of 5 minutes. Take care.